Thank you for attending our session. Today, we are really excited to talk about our AI transformation in the call center operations. Today, we will start with why it matters to us. We will show you some use cases, some numbers of it, and then we will follow with our general architecture about the call center process flow. And after that, there will be part of the like a lessons learned session about this journey. And after that, our young, talented data scientist Firangiz will dive into the details of it, especially in our speech-text model details. And we have achieved business numbers. After that, we can share these results with you. Okay, let's begin. Before going to the agenda part, I just want to talk about a little bit our institution. Kapital Bank is the first bank in Azerbaijan, and we are almost half a population as our customer. That means that our population is just nearly 10 million. And I want to highlight two different products we are having right now. One of them, we call that Ayla, is just our virtual assistant for the call center, and which will be talk about little part of it today with you. And the second one, the Beer Bank, is the first mobile banking application, and it's the most downloaded application in Azerbaijan. And lastly, I want to say that we are using Dataiku almost 3 years, and it's thanks to this, it's provide us to use cases in the production really small time. Thanks for the team, all the team. And here's our agenda. First, we'll dive into why this matters, and then we will show you the process flow, because there will be a lot of technical things after that, and I don't want to miss you somewhere. So we will show you the general at the beginning, and then dive into the details. And our strategy part includes 2 lessons learned session, and we have a lot of problems during this journey, and we get a lot of problems on it. We need to solve these problems by one by, and we will talk about that. And after that, the technical things about the models will start, and results and finished. So let's look at these numbers in the top and side. You can see there's a little bit complicated, but I will explain. Imagine you are in the institution and you get nearly 500,000 calls every month. This is a huge number of it. And when you do this simple analysis of it, you can realize that, okay, half of these calls can be automated. And at this point, we opportunity that, okay, we must do that job because there's something about it. And if you do simple calculation after that, imagine we have average call duration in 90 seconds. So that means that if we automated all this tasks, it gives us nearly 34 full-time employees workflow. So that's a huge number for it. And it gives us some benefits. First benefits, as I told you before, we can increase the efficiency in the customer experiences. Imagine you are in the call center. You are waiting too many times to call the operator or something like that. You are in the queue. So if you do this AI transformation, you don't want to wait anything. So you just call and get the answer immediately. So it's it hits your customer satisfaction scores. So it's a win-win. And the second benefit is ability to reallocate staff to complex value-added tasks, such as they can sell the credit cards, they can sell the credit loans, similar this kind of thing. So we can move these guys to another departments easily. And the third one is the data-related benefits, because real-time transcriptions and insight into call reasons is not stored in the beginning. So you have a lot of voices in your system, but you couldn't do any use cases of it because it's just format is the voice. You have everything, but you cannot do anything also. So the third benefit is that after that journey, everything transcribed in the database, in the text format, so you can do anything you want after that. You can do sentiment analysis, you can do real-time dashboards, topic detections, so on. So that's for the why this matters part. Let's move on with our integrated flow. In the top, you can see the lines. When the customer calls the call center, the voice says that, okay, I'm in the virtual assistant, please describe your problem in a single way or in 2 sentences. After that, system records just 5 seconds and send all the information about our speech text and reason classification API, which is developed in the Dataiku. There are 2 models in it. The first model is just based on the speech text model, gives the voice input and returns to the transcripted text. And of course, we feed that information with our spelling correction algorithm. And then this clean data sets move for another API. It's just the second one, just the text classification model. And the final of that, the call reason is returning our call center developments. So before do the demonstration, little bit demonstration, I want to highlight these numbers because in the ready solutions such as Whisper and Valve-to-Wake models, doesn't work in the low resources languages like us. If you try it, you will find it. This is the first number, it's just our baseline score. We didn't do any fine-tuning step, we just use as it is. And this is the higher number we can get, 35 accuracy. So after fine-tuning, we reached the 90% of it. So we really recommend you to, if you face this kind of problems, you can do the fine-tuning because it will work. And I will show you the little demonstration because to be more understandable, there will be you will hear some voices, and after that you will the transcription of that and the final category of it. Let's begin.
Kartım bloka düşüp.
You can see. Even if the noisy background, it's worked well.
O mikro kredisiyle alakalı.
You can see there are noisy background, even if that problems, the systems work well because of the fine-tuning. Otherwise, you couldn't get this kind of results. And this is my favorite part of that entire section. I will talk about some challenges and their solution of it. The first challenge we faced in the long recording of calls, at the beginning of the project, we didn't have any structured data set for fine-tuning or labeling it. So we just have the call center conversations between the call center employee and the customer, that's all. So it's really hard to label this kind of data sets for the labeler. Imagine you're a labeler, you need to label a lot of things. You need to listen, hold the conversation, and identify the detect, okay, what is the reason starts, which seconds the reason start, and which seconds the reason end. After that, you need to write the text descriptions and select the main category of it. So it's really huge amount of work. Even you need to more than 8,000 labeled data set. You need to do better results. So it didn't work. We stopped working like that and move forward the solution. We told our call center guys to develop the data collection system first. We develop a system just collect the data sets, so empty model. It didn't returns anything to customer, just direct the customers to the operator. but collect the data set. We collect more than 2 months, a lot of data set, and then we start to labeling in it. And the other challenges, time-consuming labeling process and the prone-to-human and technical errors, we solve this issue with developing web application with Dataiku. Our guys just couple of hours develop their own labeling application in Dataiku and start to label them, all the data set, because after that, we just structure data, just 5 seconds of voice, that's all. So the labeling process getting easier. Just listen the voices and write in the as it is and select the reason of it. So the last challenges we faced on the obtaining fast real-time responses under 1 second, because in the online application you couldn't get too many waiting times for the customer because they are in the queue, so you're gonna be fast. To solve this issue, you know, the GPU integrated into API solve our problem at that point. And I just want to highlight the GPU part. You don't need to fastest and largest GPUs at this point. So we just have 5 seconds of voice, so the oldest card also solve your problem. You don't want to need to cost a lot of things. And that's all for my part. I will give the words to Firangiz for the rest of it.
Thank you. So here you can see the web app that we just talked about. So we utilize the main two opportunities from Dataiku, which is code studios and publishing code studios to web apps. And here you can see, this is our labeling web app, which was made available to many people, labelers, namely, and they could just come and choose their name, listen to the audio, manually write the transcriptions, and save it to the dataset, which was in the flow in our project. And the good thing was that this dataset that we were saving our transcriptions to, it was being quality checked. So every once in a while, the people that were doing the same labelings, but the similarities were being looked at, and if there was any discrepancies, then it would get highlighted, and we would recheck them. So this had helped us a lot during the labeling process. And once that was clear, that labeling was the way to go, obviously the fine-tuning was the next step, fine-tuning of speech recognition models. And here we looked at two famous ones, which was the Whisper from OpenAI. So this model, also available in Azerbaijani, available in 99 languages, and was trained on 700,000 of data in a supervised manner. And it didn't perform well without fine-tuning. And the second one was WAF2WEC 2, which was a relatively earlier model from Meta AI. But this was the specific checkpoint for massively multilingual checkpoint, and it supported many low-resource languages, including Azerbaijani. And we compared their performances, and we saw that, for example, after fine-tuning, with very little fine-tuning, we saw that, remember, we have to hit the KPI that the inference speed should be less than 1 second. So we saw that there wasn't much of a difference after fine-tuning these two models, and we went with WAF2WEC 2. But we weren't sure how much data was needed. So we did some research. And this was actually, these tables are from their own research. And we observed that after 10 hours of data, I mean, you can see the difference between 1 hour and 10 minutes and 1 hour. There's a huge difference in word error rate. I'll just quickly say what's word error rate. So basically, the lower is the error rate, the better the model's transcription skills. And in this case, for example, if I say 100 words and 10 of them are incorrect, then word error rate here is 10%. So, and we can see that as we increase the amount of audio data in hours, we can see that between 10 hours and 100 hours, there isn't much of a big decrease in word error rate. So we decided that we should have something between 1 hour and, 5 hours and 10 hours. And this is what we went for. And the second step was a classification step. So this isn't just speech recognition. The second step is the classification of the inferred texts. And so here we tested 3 methods. It was a machine learning approach, simple algorithms, like for random forest, could be ensemble algorithms. We looked at small language models, fine-tuning them. And we also looked at some new methods, such as zero-shot classification. I'll immediately say that zero-shot classification didn't really perform well on Azerbaijani because there weren't any good pre-trained models. So we just checked that out immediately. And we fine-tuned a BERT model, and then we we did a TF-IDF vectorization on our text, and then did some multi-class classification models. And comparing these two, and keeping in mind that we should keep our inference duration as low as possible, we went with the first one. And also 5 seconds of audios, there isn't much that can be said during that period. So yeah, the first one was the way to go. But we also included the final step, the spell checker step, and this was to compare our inferences, our transcriptions, to our based dictionary. And this is because, as you can see, after we add a spell check, the accuracy of the overall classification model increases by 5%. So this could be done, for example, if you had collected more audio data and fine-tuned or more data, maybe you could have seen this change. But but without doing that, we can just, by using a simple spell check step, we can increase the accuracy by 5%. So I'll just quickly go over. This was our final data counts, data representations. So for fine-tuning, we had around 5,500 of audio samples, which equaled 7.5 hours of audio. And this was for fine-tuning. We had a very easy flow on Dataiku, which was the audio directory, and the manual transcription of the audio. And the next step was, from that fine-tuned model, obtaining the texts. We had around 10,000 texts and their category labels. And here we were helped by the labelers also, who knew what transcription matched to which category. And we had, for our use case, we had 8 reason categories. And this was our second model training. And once it was all done, we had to deploy it to an environment where it could be used. So we went to create an endpoint. And first, we wrote our simple Python function. We developed it in API Designer, again, on Dataiku. And once it was done, we could deploy it to API Deployer, also from Dataiku. And we also enabled GPUs. And as you can see here, the total response time now was 0.08 seconds, which was perfect for our case. We had to keep it under 1 second. With CPUs, we tested it was around 1 to 2 seconds. But in this case, with the power of GPUs, we could increase it 10 times. And yeah, I will just shortly talk about who contributed to this project. And there were many departments that worked together. Obviously, the main project roadmap, the idea started with product owners and business analysts from our call center who defined the needs and what needed to be automated. And then came data scientists who just calculated the feasibility of this project and did the research, the fine-tuning, the model training. But obviously, their work wouldn't be possible without the help of data labelers. And they didn't really know why they were doing it, but they were still doing it. So, and finally, as I talked about APIs, it was really made easy with the help of DevOps engineers and data ecosystem admins, who just made it possible to smoothly deploy the API to the production environment. And here, this is my favorite slide. So here we talk about results, as you can see. In general, from the technical point of view, we were able to achieve 25% word error rate, which according to Azerbaijani benchmarks is a pretty good number. And overall, like the pipeline's accuracy was around 90%, including the spell checking step. I mean, I already mentioned the data API integrated with the GPUs, but this was very important. So, we didn't actually open the system immediately to all of our customer base. We started slowly. We started with bank employees first. It was our first deployment in November of 2023. And then subsequently, we just increased the percentage of customers that were able to access this system. And now we were open to all of our customers. And since then, we have seen a 22% increase in the first call resolution rates. So by using our pipeline, it was possible to simply resolve the customers were able to resolve their use cases immediately. There was also a 32% increase in the number of users of this pipeline. So they weren't skipping it, they were actually using it. The queue waiting times were shorter, and a very important point was that we were able to hand over this project to business departments who are now fully capable of training their own models, doing any updates that they need to. And this was also very important because the transfer of know-how to other departments and usage of Dataiku was also one of the main milestones of this project. And last but not least, we were awarded Best Use of AI in Digital Transformation Award by Global Finance Magazine. Our bank was awarded. And before finishing, I just want to show you some. So this is our corporate Slack, and Sadiq is our DevOps engineer. He's the one who made it possible to deploy it seamlessly, our API. And this is his conversations with me when I need him to do something. So this is, I was asking him about test environment, and he was fixing it. I was suggesting maybe update NVIDIA. I didn't expect him to send his own picture there, but OK. And then, yeah, once it's ready, he's just sending, another meme, and I'm just thanking him there in Azerbaijani. So thank you.